Hi everyone. Let me know if I'm audible. You can let me know if I'm audible. You can simply write like audible or something so that I can start the session. Okay, thank you. So great. So well, today we'll talk about hashing, right? Like what is hashing and how we can use hashing technique to solve some very common coding problems, right? So that is the agenda of today's lecture. Okay, awesome. Uh, Let me quickly share my screen and then I'll start teaching, right? But as I said, today I'll talk about hashing only, right? Like what is hashing and how we can, uh, implement hashing and what is the use of hashing, right, to solve something. So that's the idea. Let me share the screen. Okay, I hope you can see this whiteboard. Okay. Great. So let's do one thing, right? Let's say uh, let's understand like what is the need of hashing and then we'll see like what is hashing and how it is so helpful, right? Let's say we have to let's say we have n integers, right? Okay, and let's say n is very large. Let's say n is 10 to the power 9. So we have 10 to the power 9 numbers, means we have 1 billion numbers, right? And let's say we have to do three things. One is like let's say we are designing a collection or we are designing a data structure, right? Uh, or I would say we are designing a collection or some group of items, group of integers, right? And let's say we have to support three operations. One is insertion, like someone should be able to insert something like x, an integer x in that I would say that group, right? So let's say we have a group of integers, right? And the max size of group can be 1 billion into the power 9, right? That's the idea. And we should be able to insert an element, an integer in that group or in that data structure. Apart from that, let's say I want to delete an integer from that collection or from that group, and let's say I also want to search something. Whether search means it should be boolean, right? Whether we have that element or not, right? So like let's say if we have a collection like this, we have 341, then 12, 15, then 20, right? Let's say we have 5 elements. Insertion means let's say if I want to insert, let's say 30, right? So we should be able to add 30 to this list. Deletion means let's say if I want to delete uh, 12, right? So we should be able to delete this 12 from this collection, from this list of, or let's say this is list, right? This is list or collection. Okay. So basically it's a group of, let's say integers, right? Again, it can be a group of anything. It can be a group of integers, doubles, anything, right? But let's say for now, it is a list of integers only, right? It's a group of integers. And search means we have to check whether we have an element, like let's say if x is 15, so we have to check whether 15 is there in this list or not, right? So 15 is there, so it should return true because 15 is there, right? So let's say we have to support these three operations: insertion, deletion, and searching, right? Okay, and we have to think of something using which we can do all these things in the most efficient way, right? Okay. So what do you think? What we should use for this kind of use case? Any cases like what is the best data structure that we can use for this collection? Is this unlisted? What do you mean by unlisted? Okay, I can make this full screen. Here we go. Okay, someone is saying hashing. So someone is saying array, right? Okay, let's say we're using array. The first issue with the array is it is not dynamic, right? Let's say if you are initializing an array of size 10 to the power 6, right? Uh, and let's say if you're inserting only 10 to the power 3 elements, right? So basically in that case, we'll waste a lot of space, right? So arrays are static, like we can't increase the size of array to runtime. So that's the issue with the array. For that, we have something called dynamic array, which can grow at runtime, right? So for dynamic array, we have inbuilt dynamic array. Like in C++, we have vector. So vector is nothing but a dynamic array. In Java, we have array list. So this in Java, we have array list, which is dynamic array. Again, it's an array, but it can grow at runtime. Like the size of the dynamic array can grow at runtime, and this is for C++. Okay. So, okay, let's say we have dynamic array, and let's say this is only 1 million, so that it can fit easily in the RAM. Okay. Yeah. So let's say we're using dynamic array like vector or array list. Then what should be the cost of insertion in this dynamic array? Okay. Let's say if I'm using vector or array list for this kind of use case, then the cost of insertion will be like I can simply insert at the end, right? And that will cost only O of 1. So if you know about vector, or in fact in array, you can easily append or you can easily add one element at the end in constant time, right? In O of 1, in constant time, you can insert an element in the array or in the dynamic array. Okay. Yeah, so okay, let me state it again. What I was saying is we have to design a data structure or a list or a group, something. Basically, we are storing a list of a group of integers, right? Like this. And we have to support 3 operations. One is insertion, second is deletion, and third is searching, right? So we have to do all these 3 things on that collection, on that list, on that group, right? So which DS is best for this use case? So we are talking about array, dynamic array, and insertion is in O of 1, right? What about deletion? Let's say if we have these elements in the array like this, 3, 41, 12, 5, 20, and so on, right? Let's say I want to delete 12 from the array. So in that case, we'll have to shift all the elements to the left, right? And that shifting will cost O of n. That's why deletion in array or deletion in a dynamic array is O of n, right? It will take O of n time. It's it's a linear operation, right? And what about searching? What is the cost of searching uh, in a dynamic array or in a simple array? Yeah, searching will take big of n time again because it is not sorted, right? So searching an element in a in a dynamic array or in a simple array can take O of n time, right? So again, I mean, array is one option, like dynamic array is one option, but it is not the best option, right? So can we do something so that we can do all these things in constant time? Can we do something? Yeah. So for this kind of use case, I mean, to make searching insertion and deletion efficient, we have something called hashing. Let's see how we can design something using array itself, such that we can do all these things in O of 1. So we can do all these things in constant time in O of 1. So let's see how we can do that. Well, so let's say I have an array. Let's say the array name is hashing. And let's say its size is 10 to the power 6. Okay. Okay. And then let's say what we are doing is we are simply okay, let's say for now all those numbers are unique, right? Let's say we are inserting only unique elements in that list, right? So we have to submit things: insertion, deletion, and searching, right? So what we can do is uh, let's say if you're going to insert 30, right? Okay. So let's say initially all the values in this array is 0. Okay. So basically at each index in this array will have 0. So we are initializing this array with the 0, right? So the value of the value at each index in this array will be 0, right? So what I'll do is I'll simply do, let's say, hashing of. I'm assuming that the range of numbers are from 1 to, let's say, 10 to the power let's say 10 to the power 6, right? So let's say the numbers are in range only, from 0 to this range, right? So what I'll do is let's say if I'm going to insert x, so what I'll do is I'll write hashing of x equal to 1. I'll simply mark uh, the value at that index as 1, right? Okay. In deletion, what I'll do is I'm going to delete again. Let's say again I'm inserting 20, right? So what I'll do is I'll again mark 20 for the. So let's see how this thing will help us in searching, right? Again, by simply writing a variable like this, it looks like this voice issue. Okay. Okay, let me check the. Okay, really sorry for the voice issue. Well, I hope this should be fine now. Yeah, there was an issue in the network, so I think that is fixed now. So it should be clear now. Am I audible now? So I have fixed the audio issue, so I think it should be clear now. Let me know if everything is fine. Yes, I'll repeat the last 1 minute, don't worry. So I'll repeat the last things, right? Thanks. Okay. Let me quickly share my screen again. Start from the first, okay? Well, yeah, so what I was saying is we can, okay, what I was saying is we can simply, so I'm using an array, right, of size 10 to the power 6. And let's say initially all these values are filled with 0, right? Okay. And when we are inserting x, let's say I'm inserting 30, right? In that case, what will happen is I'll mark hashing of 30 equal to 1. Okay. Similarly, when I insert 20, I mark hashing of 20 equal to 1, right? So basically, again, the cost of this operation is O of 1. We are simply assigning something, right? Hashing, like, it's an array, right? So hashing of 20 is equal to 1 or something. This operation will take only O of 1 time. So basically, we are inserting something in this array or something in that, I would say, let's say, new DS called hashing in O of 1. So I hope insertion is clear, right? Like how we're inserting things in the uh, array. Not audible, seriously, okay? So I take some time pause. So okay, so if I'm taking some pause, so that will be not audible. Well, so what I was saying is, like insertion can be done easily, right? Like hashing of x equal to 1, right? And hashing of, let's say, 20 is equal to 1, right? And so on. So this is how we are doing insertion in this array, and that is taking only O of 1 time. Now let's talk about searching. Let's say I want to search whether 15 is there in this DS, in this collection or not, right? So what I'll do is I'll simply check if hashing of 15 is equal to 1, that means, this value is there, right? So return true, otherwise return false. So this thing, I mean, again, this comparison can be done done in O of 1, right? So we're simply checking the value at index 15, right? So this is O of 1 thing, right? So this is how we can search something in O of 1. Okay. Similarly for deletion, let's say I want to delete 20. So what I'll do is I'll simply do hashing of, let's say, 20 is equal to 0. Okay. So again, this has cost O of 1. So now with the help of, you can say, an array, okay, what we are doing is we are doing insertion, deletion, and searching in O of 1 time, right? So this technique is called hashing, in which we use an array. Again, we will talk about other things like what is collision, what is hash function. We'll talk about this thing, but this is the basic idea of hashing. Like if we are using something like array, then using an array, we can do insertion, deletion, and searching in O of 1. Okay, so that's the beauty of array. And in hashing, we use normally array. Again, we will use dynamic array because so that we can have variable length of that hashing thing, right? Okay, but this is the basic idea. Like if we are doing something like this, so this way we can do insertion, deletion, and searching in O of 1. Let me know if this is clear. Okay, someone is saying, what if the value is greater than hash size? Okay, so I'll come to all these things, right? I hope this thing is clear, right? Like how we are doing things in O of 1. What if 0 was already there in the data, that making it 0 is not considered deletion? Well, okay, so in that case, what we can do is we can simply check if that element is there, then only we'll delete that, right? Okay. Or let's say again, let's say if 20 is not there, then also we can write hashing of 20 equal to 0, right? So that will not affect that thing. Yeah. So we can make it simply 0. So any doubt like how we are doing all these three operations in O of 1? Element is inserted in the square bracket. Yes. So see, hashing is the name of array, right? So hashing is nothing but the array. Okay. So it is something like array of 20 is equal to 1, right? So you can replace this hashing variable name with array because it's a simple array. Okay. Well, so the question is, Manpreet is asking if the value is negative. That's a really good question. Well, another question can be if the range of this number can be more than Okay, so this will only work if the number is in this range, right? 0 to 10 to the power 6, right? Because let's say if the number is x equal to -5, right? So in that case, you can't write something like array of -5 equal to 1. You can't write this, right? Okay, so that's where we have something called hash function. We have something called hash, right? So hash will convert this value to some index in the array, right? Okay, so I'll come to that point later. But let me know if you understood this thing, like how this is working. Yeah, Kirti, this is increasing space complexity, right? But we are more concerned about time, right? Time is more important than space. Space can be bought easily, right? So that's why I mean we care a lot about time. We don't care much about space, right? Okay. So I mean, nowadays space are not that costly. Like you can buy a RAM of let's say 16 GB in some some thousand of rupees, right? So that is I mean RAM is not that costly, right? Okay. I mean, it is costly, but if you compare with the time, time is much more costly, I would say, right? So that's why if we can optimize, we can reduce the time complexity of something using something, then, I mean, using extra space, that is a better option, right? And that's what we do in caching. If you know what is caching, in caching, we do the similar thing. We use extra space just to reduce the time, right? And also in data in DP in dynamic programming we do the similar thing. We simply use caching kind of thing. We memorize things to make it faster. Yeah. Okay. Use of hashing. See, okay. I'll talk about the questions on hashing, like how hashing is that important, right? So now let me talk like how this will work for negative numbers, right? So let me come to that. So let's say if the range of numbers are, let's say, from -10 to the power 5 to 10 to the power 5, right? Something like this. And let's say we have that array in which we are going to insert. So this is the hashing array that we'll be using. Okay. And so on. So let's say if you're going to insert something like 10 to the power, something like, let's say, -35, right? So I mean, we can't write something like this, array of -35 equal to 1. We can't do this, right? So we have to convert this number -35 to something. Let's say if the size of this array is 10 to the power 6, right? So we have to convert this number in some number index, and that index should be in this range from 0 to less than 10 to the power 6. Then only we'll do something, right? So to convert the actual value to a number to an index of the array, we have a function called hash. So that hash function will help us to convert any value in this range so that we can store in the array, right? So that's the idea. So like, let's say if we have -35, so what we can simply do is we can, let's say, add something like 10 to the power 7, right? Okay. So we'll have, okay, so let's say the hash function is quite simple. Int hash, right? So let's say we have a hash function, and what we will do in the hash function is we'll write any, let's say we have a number, let's say this is x, right? So x. So we'll add 10 to the power 7 in the x, and then we'll return uh, x mod n. Here n is nothing but the size of the array. Let's say here n is 10 to the power 6. It is size of the array. So basically this will give us, again, this will make any number as positive, right? So let's say if we have minus, this number, then also this will be positive, right? Again, we can add any other function, but let's say I'm writing a simple hash function, simple hash that will, give us a number. So now this value, I mean, this function will return a value in the range of 10 to the power 6, right? So less than 10 to the power 6, because we are taking the mode with n, right? So right, so now we'll have that index. So what I'm doing is so let's say if x is minus 35, so what I'm doing is I'm finding an index which is nothing but the hash of x. So let's say we have this number will be, I guess, 35 only. Yeah, well, so what I'll do is I'll write array of 35 is equal to 1. Okay, and let's see how searching will work, right? So let's say if I want to search whether minus 35 is there in the array or not, so how we can do that? Like how we can search whether minus 35 is in the array or not, right? So what we can do is we can simply find the index, and again, so this is the actual, right? So we'll have to find the index first. So the index will be nothing but uh, again I'll find index equal to hash of that x, and again I'll have 35. So I'll simply check whether sorry, whether this 35 is there in the array or not, right? So it is there. That means okay, minus 35 is in the array, right? So now what we are doing is we are simply converting that value, that x, to an index, right? Using this hash function. And then we are working on that index. We are either making it 1 or 0 or something. Okay. Again, in deletion also we can do similar thing. In, let's say if I have to delete minus 35, we'll do similar stuff, right? We'll find the hash, which will be equal to 35, and we'll write array of 35 equal to 0. Okay, so that's a simple thing that we are doing. Here we have one more thing, like at the same index we can have multiple values. Like let's say if the actual value is 35, let's say we are going to insert 35, right? In that case also we'll have we'll have a value, like again in that case also the index will be like, let's say if I'm finding the hash of 35, right? So we'll have index is equal to 35 only, right? So now basically for two values, for minus 35 and for 35, we are getting the same index, right? We are getting the same index as 35. So now how to handle this situation when the hash of two values are same? That is called collision, right? Collision means these two values are colliding with each other. Colliding means they have the same hash value, right? And how we can handle that? So for that thing we can do one thing. Let me show you. So now at each index, let's say this is an array, and we are at index 35, right? So at this index, what we can do is we can enter these two values. The one value could be let's say the one value was minus 35, and then next value was 35, right? In fact, we can have, let's say we have one more value called, let's say I would say the next value could be, again, let's say if you have something like minus 1000035. So in fact, the hash of this value will also be 35, right? So that value should also be stored at this index, right? So what I'll do is I'll have a linked list kind of thing, right? At each index, like at index 35, at index 1, at every index will have a linked list, and or any list, I would say, and in that list we'll be adding all these values, right? So now let's say if you let's say if you are searching for sorry, this is 1000035, right? Let's say if I'm searching for 35, right? So what we will do is, okay, so now it's not similar to simply doing like array of 35 equal to 1, right? It's not the case. We have to use either a linked list or something at each index of the array, because at the same index we can have multiple values, right? Because we have the case of collision, right? So in case of collision, at the same index we can have multiple values, and to handle that collision, what we have done is we have a list where we can store all the values which has the same hash function, right? Which has the same hash function, right? Okay. Let me know if this hashing concept is clear clear to you. Mhm. Okay, what if number is repeated? Yeah, that's another question. Okay. Right. Okay, some of you are able to understand that's a good thing, right? Okay, linked list. Okay, I mean again, it's hashing is okay. So for now, what you can do is, I mean, if you remember the previous example, again, I mean, the previous example will only work if we have the numbers in the range of this, right? But let's say if I want to store a string, if you want to store a float, if you want to store a double, if you want to store a structure within the hash map, right? So we have to convert that value. Again, that value can be an integer, that value can be a negative number, a float, a double, a string, an object of a class or something, right? Or structure. So if you want to store that thing in the hash map, we'll have to convert that value to a integer called index of this array, right? And for that thing, we have something called hash, right? Okay. And that hash function will help us to, convert that value to an index, and we can go to that index and we can add that value to that index, right? See, if we have a simple array, we can only insert that thing, we can only, insert only one value, right? We can't insert more than one value. Here the case is that at the same index we can have multiple values, like we can have minus 35, we can have 35, and so on, right? So multiple values can have the same hash function, right? Okay. And that's the collision. Okay. So that's why we have a list. Again, that list can be linked list or anything, that can be anything, right? The idea is we want to store multiple things at the same index. That's why I'm using a linked list, right? You can go with anything. You can go with another array or something. The idea is simply store multiple values at the same index, right? So that we can store multiple types of values, negative values. In fact, we can store strings as well in a hash map, right? Okay. Uh, so, but again, we are using array, and we are again doing things in O of 1 in best case. But now the thing is, in worst case, let's say if we have k elements in this linked list, right? And let's say if you're searching whether 35 is there in the hash map or not, right? Or in the hashing or not. So what we'll do is we'll have to find the index, we'll go to that index, and we'll iterate in that list to check whether 35 is there or not, right? So that searching can take O of k time, right? K is the size of the list, right? So in worst case, it could be O of k. Again, we can use something like, we can use something else, like we can use a balanced BST. I mean, if you don't know what is balanced BST is another DS, another data structure which can help us to search something in login time, right? So if you're using that thing, then we can search in login time in worst case. But again, the best case and average case in hashing for insertion, deletion, and searching is O of 1 only. Because if you have a good hash function, then you will have rarely collisions, like right, like the two for two values you will not have a lot of collisions, right? And let's say if you have some collisions, like let's say at the same index you have three values, so you just have to search in those three or four values. So that will again take constant time, right? It's very rare that okay, that list will be so long. Okay. So this is how we are still inserting, searching, and deleting in O of one time. Okay. Let me know if this is clear. Well, the idea is okay. The idea okay. How we are making the difference? See, we are storing all these values one by one, right? So we are storing -35. We are storing 35, and so we are storing everything, right? Okay. Let me explain with simple example. Let's say we have an array of size 10, right? And let's say the hash function is simple. Return x mod 10, right? It's that simple. And again, we are adding x equal to x plus, let's say, 10 to the power 7, just to make things positive. Uh, hmm. So let's say we are going to insert 37, right? So in that array, what will happen is the hash of 37 will be 7, right? So we are getting index 7. So we'll go to index 7, and again, we'll have a list at that index. So we are adding 7 in that list. This is index 0, 1, 2, and so on, right? Let's say we are going to insert 24. So we'll go to 24, like let's say we have 4. So we'll add 24 here. Sorry, this should be 37. Sorry, this should be 37. Yeah. Let's say we are going to insert 57, right? Again, for this value as well, the hash will return index as 7. So we'll go to again the same index 7, and I'll add that value called 57 in that list. Okay. Let's say we are again adding 57. Okay. So in that list, we'll again add 67 because it will have the same hash value 7. Okay. Now let's see how we can, let's say if I want to search, now I want to search 57. So what I'll do is I'll simply find the hash, which is 7. Okay. With the help of this function, I'll go to that index. Okay. And then I'll iterate in that list, right? And in that list, we'll find, okay, we have a number called 57. That means, okay, this 57 is there, right? So let's say the size of this list is not that big. Let's say the size of this list is O of k. So in worst case, the time complexity could be O of k. But normally, this list will not be that big. The size of this list will be, let's say, 5 or 10 only, right? So in average cases, or in the best case, it will be only O of 1, right? But yeah, again, in the worst case, it can take O of k time. If you're using a list, again, you can use something like balance BST, in which your search cost can be reduced to log n time. So we'll talk about those things when we'll discuss about trees. So this is how we are differentiating between multiple values at the same index, right? Because we have the list which is containing everything. Now let's say I want to delete 67. I'll do the similar stuff. I'll find the hash, which is 7. I'll go to that index. I'll iterate in that list, and I'll delete that node, right? So this is how we're deleting. Okay. So I hope this is clear now, like how we are. Again, insertion is in overflow, right? In some cases, we might have to insert, let's say we are inserting 44, right? Which will go to the same index, right? So again, we are iterating in this list, but the size of this list will not be that big because we'll have a good function. The size of the array will be really good. So we'll have we'll have a scattered value, like at each index we won't have multiple values in good cases, right? In ideal case, I would say. So this is how we are still doing things. like searching, insertion, deletion in constant time. I mean, the average cost is O of 1 and the best case is O of 1. But in worst case, it can take O of k. K means the size of this array. And again, the k can be equal to n in the worst case, right? But that is not going to happen because we'll have a good hash function. The size of this array will be good so that we can have, you know, multiple entries, multiple indexes, right? So yeah, so we won't have a lot of values at the same index, right? Okay, now someone's saying go to this. Thanks. Mhm. Okay, any other doubt like how things are working here? Can this be again a hash table? Okay, so you can call it hashing or hash table or something. Yeah, this is called hash table. I mean, it has multiple names, right? Well, so again, the one way is we can write our own hash function. Like let's say if we want to store strings in hash map, right, in hashing. So for that thing, we'll have to write, like we'll have to convert the string in integer, right? And then we'll have to store that string in an array. Let's say now I want to store strings in the hashing. Basically, I want to insert, delete, and search a string. Let's say I want to insert ABC. Then I want to insert, Ramu. And I want to search all these things and delete all these things in O of 1. Let's say I want to search whether Ramu is there or not, right? So I'll do the same similar thing. I'll have an array. Let's have size 10. Again, if I talk about the hash function, what I'll do is in the hash function is in the hash function we'll have the value, right? Which we are going to insert in the array, or I would say in the hash table. You can call this array as hash table. Okay, so this hash will return again the index of the array. So what we'll do is we'll have to convert this string to integer, right? So what we can do is we can simply iterate in this array and we'll find the sum of sky values of all the characters of this string. Like for A, the sky value could be, let's say it's 92 plus, let's say 92 and so on, right? I don't remember the sky value. It came in 97, I guess. I don't remember. So basically we'll have an integer and then we can simply return by taking mode with 10 because 10 is the size of the array, right? So let's say if I'm inserting ABC in the array, so let's say this function will return 4. So we'll go to 4 and we'll insert ABC in this list. Let's say we have one more string called BC, right? So they will have the same sum, but it's a different string, right? So they will have the same index 4. So the same index will have BC, right? Again, we can have multiple other strings. Like we can have something like, let's say if you have something like ACD, then we can have one string called, let's say, B, then A, then E, right? Okay. So they will also have the same sky value. I mean, the sum of the sky value will be same, right? So they can have the same index, right? Yes, that string will also be at the same index, right? So basically, this is how we can also insert strings in the hash map, in the hash table. And again, we can do insertion, deletion, searching in O of 1 time. That's the beauty of hashing. We can do these things in O of 1 in the best and average case. In the worst case, it can take O of n time, and we can optimize that to log n time if you are using something like BST, balanced BST, like red black tree or a wheel tree. So we'll talk about those things when we'll discuss trees. But I think for now these things are clear. Well, okay, yeah. So you can write anything. Like we can convert anything to integer, right? Yeah. So you can explore more about hash function, like how we can write a good hash function. So you can read about that from YouTube and from other websites. Well, so normally we don't need to write all these things, right? So in C++ or in Java or in Python, we have inbuilt things. Like in C++, we have something called unordered map, and then we have something called unordered set, right? So basically we'll have, like, in unordered map, we'll have a key value pair, right? In Java, we have hash map, or we have hash set. So if you don't know these things, okay. So in unordered set, what we do is we keep only one value, right? In map, what we do is we keep two things: key and value, key value pair. Okay, the one example could be, and again, so basically in hash map, we'll have a key value pair. In hash set, we'll have a single value. Like, let's say if I want to store the age of a person, like let's say Ramu has age 20, right? Let's say Ramu has age 20. Raju has age 30. Then Raka has age 40, and so on, right? So, uh, okay. So basically, Ramu is key and value is 20, right? So basically, we are storing something as a key value pair. So for such kind of information, we can go with the hash map, and we can go with the unordered map in C++. So when I use this term hash map means unordered map in C++, right? So it's a hashing, and we can insert this thing in O of 1. We can delete this entry in O of 1. We can search this entry in O of 1. Like, let's say if we want to find the age of Ramu or Raka, I can do that. I can search the age of Raka in O of 1. So in that case, what will happen is, in the array, like last time we were talking about unordered sets because we had only one value. But let's say if you want to store a key value pair, then we can store two things. Like, let's say in that list, we'll have two things. Let's say Ramu and 20. Let's say we have Raju has, let's say, same sky value or same hash function. In that case, Raju will also be in the same list. Okay. But again, instead of storing a single value, we are storing two things. One is key and one is value. And again, we'll be doing hash of only keys so that we can insert and delete and search with the help of keys, right? Because let's say if you want to search the age of Ramu or Raju, right? So we will just passing Raju, we'll just passing keys only, right? So we'll find the hash of the key. Let's say we're getting 4. So at the 4 index, we'll insert these things. Basically, we are storing both the things, key and value. In unordered set or in hash set, we store only value. We just talked about that thing in the last example. Well, yeah. So again, these things are already inbuilt in C++ and Java, right? So let me show you something like how we can write the code for C++ or Java. Well, so I won't take much time. So for C++, what you can do is you can write let's say uh, let's say I'm simply storing the frequency of a number, right? This is map, or let's say this is a hashing. This is a map, right? So I can simply write map of 20 is equal to, that means 20 is the key and 30 is the value. Okay, let's say this is a string, right? So that it will make some sense. Let's say this is a string. Let's say age of Ramu is 30. We can insert things like this, right? And this will take O of 1 because we are inserting something in the hash, so that won't take more than O of 1. We can have something like map of, let's say, 1. as 40, right? Again, so basically we are inserting something. So this insertion operation will take offline. Let's say if you want to search something. Search means we want to get something, right? We can simply, let's say if I want to know the age of Ramu, right? So what I can do is I can simply return the map of Ramu. So this will give me the age of Ramu. This will give me the, this will return 30. Okay, to delete we can simply, so we have a function called delete, we can delete that. So in Java we do similar stuff. Like in Java we have hash map, right? Right, a string, hash map of string, and okay. So on the codes page, let me show you that thing. Actually, on codes page you can easily find all these things. Like you can go to the codes page. Uh, so you were talking about DSA workshop, yeah. You can go to the hashing track. These tracks will be published sometime, right? So in the hashing, you will see the thing, right? Like what is hashing, what is do things, then how to write code for hashing in C++, right? We have unordered set and unordered map, right? So here you can see sample example to use those things, like how we can insert something. Either you can use insert thing, or you can simply use the way I use that, right? Or you can do one more thing, like you can go to GeeksForGeeks and you can go to C++ and you can learn about like how unordered map works in C++, right? So we have, yeah, so here we have the unordered map. Let me check. So here you can see things about map. Here we have map, multi-map. Yeah, so all these things are there. You can look at that. Similarly for Java, you can do the similar thing. You can go to Java and you can explore like how to write code using hash map, right? Yeah, so here we have hash set. Here we have hash map, right? So you can explore about like how to write code for hash map, right? Yeah. And these things are allowed to use in the interviews. So it's not the case that okay, you'll have to write your own hash map in the interviews. You can simply use the inbuilt hash functions, I mean hash map or unrun map in the interviews, right? So let's solve some questions based on hashing. Okay. So let me know if you have some more questions regarding hashing. Again, you can't learn hashing in 1 hour. So this is just the beginning, right? So yeah. Okay, let's solve a problem. Let's say we are given an array. Let's say we'll have elements like this. Okay, let's say if x is 20, right? So we have to check. Oh, okay, let's say we have this array, right? Let's say we have 10, then we have to decide, right? So we have to simply check whether uh, this array contains duplicate or not, right? So if this array contains duplicate, then we have to return true. Okay, let's say we are writing a boolean function and this will return true if we have duplicate element in the array. Let's say we'll be given the array and we'll be given the size of the array and we have to check whether we have duplicates in the array or not. Like in this example we have duplicate, like 10 is occurring 2 times, right? So we have duplicate, so it is true because we have duplicates, right? Yeah. So how to solve this problem? how we can solve this problem, like finding the duplicate? The note will be shared in the comment of this video, right? So I'll do that and share that thing. Yes, you can try googling. Yes. Okay, so how we can solve this problem? Okay, Sania said sorting. Okay, that's nice. Okay, so sorting is one way. Yeah. So method one could be, we can simply sort the array, right? That will take n log n time, and then after sorting, it will be something like this. Like, so the good thing about sorting is it will, so the same elements will be together after sorting, right? Like we'll have 3, 6, 10, let's say 10, then 10, and so on, right? So now the same elements will be, or I would say duplicate elements will be together. So we can simply create in the array, and we'll simply check if array of I is equal to array of I plus 1. That means, okay, we have duplicates, right? So yeah, so that is the simple way of, you know, checking for duplicates, right? So sorting is one way, and this method will cost big O of n log n time. But yeah, this is one approach. Anything else that we can do? XOR will not work by counting frequency. Manpreet, yes, you are right. XOR will not work, right? Like how XOR will work. Manpreet, you're right. We can, Ayushi is asking, we can check the frequency. Yes, checking frequency is also good. Yeah. So the one thing that we can do is we can have method 2, and what we can do is we can simply have a hash map, right? And let's say it's a map of the element with the frequency. Let's say, like, in the map, I'll simply increase the frequency of that element. Like my map of 3 will be 1, and then if 3 is occurring twice, in that case map of 3 will be 2. So I'll simply, do plus plus of, so I'll simply do map of array of I plus plus. So basically we will increase the frequency of that element in the map, right? And we can simply check if the frequency of any element is greater than 2. That means, okay, we have 2 or more elements with the same value. That means we have the duplicates, right? So we can return true. Okay. So hash map is one solution. Again, we can use hash set, which means unordered set, right? So we can simply insert all the elements in the array, and if we find something which is already there, like so I'll iterate in the array, I'll be inserting all the elements in the unordered set, or I would say hash set, right? And when we'll be at 10, and we'll simply check. So before inserting, what we'll do is we'll simply check, okay, if that element is already there in the hash set, that means, okay, we have duplicates, right? So when we'll be at this index, uh in the hash set we'll have already a value with 10, right? Okay, so that means we have duplicates. So that's another thing, that's another way of solving this problem. So in method 2, what about the time and space complexity? So what is the uh second approach, right? Anyone? Can you add C sharp code? Sorry, I don't know C sharp code, so sorry. Yeah, Tara Nashib, yes, the time is 6 to 8 p.m. IST, which is, yeah, for Pakistan it will be 5:30 to 7:30. Yeah. Mhm. Okay, so what about the time and the space complexity for the solution? Great, yeah. So the good thing is that we are simply inserting all the elements in the array. So inserting one element or searching one element is O of 1. So inserting n elements or searching n elements in the hash map or hash set will take O of n time. And but we are using extra space for hashing, for hash map or hash set. So space will be also O of n, right? In this solution, space was O of 1 because we are not using any space, but time was little worse, like we are using n log n. Here it is O of n is the space and O of n is the time. So it's like it's better than the first method because we are solving it in O of n. But yeah, we are using extra space, O of n space. Okay. But let's say what if we are not allowed to sort this array? Like let's say somehow we can't sort the array, so we can't use the method one. And also let's say if you can't use the extra space, yeah, then can we solve this problem without using extra space and without sorting the array? Let me know if something can be done without this. I mean, apart from these two methods. Nikhil, I mean, for proper code, you can simply go to GeeksForGeeks website, right? Let me show you, like, okay, how you can find all these things. Like for proper code, for anything, you can simply go to GeeksForGeeks and you can find that example with the proper working code, right? Or in fact, you can go to DS, you can go to, let's say, hashing, and here you can find a lot of questions based on hashing, right? Uh, Also, you can read about the basics of hashing, like what is index mapping, what is double hashing, what is load factor rehashing, and you can, like, let's say if you want to find union or intersection of, let's say, an array, or let's say you want to check whether two arrays are equal or not, right? So again, here you can find the logic with complete working code in C++ and in Java as well, right? So yeah, so here you can have the complete code. So if you're a beginner in coding, then I'll strongly recommend you to go through these examples on each topic, right? For hashing, for sorting, for searching. Here you'll have a lot of questions and you'll have the complete working code so that you can know like how things are, I mean, how you can write code for all these things. Yeah. So again, in this class, I can't teach everything. Right? We have limited time. So yeah, so you will have to do some effort from your end as well. Yeah. Yeah, two loops is fine. Yeah, someone said two loops. Yeah, that's perfectly fine. So method 3 is using two loops, n square. See, in interviews, it's not only about the most optimized solution. It's about solving a problem in the given constraint, right? Like let's say if you can't use the extra space, if you can't use sorting, then we can find the solution in n square time using two loops, right? Like we can do for I equal to 0 to n, and for let's say j equal to I plus 1 to n. If we have a pair, like if array of I is equal to array of j, that means they are same. That means we have duplicate, right? Return true, right? So using two loops, we can do that, right? And and it is a perfect solution, right? If we have that constraint, then we will have to do this, right? So sometimes the brute force can be your best solution because I mean we are not using any extra space here. We are not sorting the array. We're not changing the array. Yeah, so this is also one solution. Okay. If you want to see the complete code, right? You can, I mean, have a look at the like you can let me search that for you. Is okay, or I would say array contain. This was the problem, right? Okay, sorry, this is a different program. Looks like. Let me. Okay, I mean you can easily find that solution. Uh, well, I'll share that link as well. So I'll share the link of this program in my doc, and I'll share that, right? So in that link, you can find the complete working code. Okay. I hope the logic is clear, right? Now let's solve the new problem, which is checking if two arrays are equal or not, right? So let's say we have two arrays like array one, like this 1, 2, 5, 4, 0. And we have another array like 2, 4, 5, 4, 0, 1. So these two arrays are equal because they have same number of elements, right? I mean they have same elements actually. Yeah. This is also equal because they have same elements, right? This is not equal because here we have two ones and 1 7, but here we have two sevens and a single one, right? So these two arrays are not equal. Yeah. So we'll be given two arrays, and let's say the size of the two arrays will be same n. So we have to check whether two arrays are same or not, right? So how we can do that? And it's a quite simple problem. So let me know if you have any issue in that. So how to find whether two arrays are same or equal or not, right? So how we can do that? Any guesses? Take your time, think about the logic, and let me know if you are able to reach to that solution. Yes, so that makes sense. Yeah. So the one solution could be we can simply wait. Let's say we have something like this, right? So what we can do is we can simply sort both the arrays, right? Okay. And after sorting, we'll have something like this 0, 1, 2, 4, 5. This will be also something like 0, 1, 2, 4, and 5. Now iterating both the arrays. Okay, like we can write something like this for I equal to 0 to n. If let's say this is array 1 of I is not equal to array 2 of I, that means they are not equal, right? So return false. So if they are not equal, then return false. And if they are equal for each value, that means okay, they are equal, they are same, right? So this is the method one in which we are using sorting. Uh, so the cost of this method will be n log n, right? Because sorting one array will take only n log n time. We are doing two sorting, so it will take n log n plus n log n, which is n log n, which is n log n itself. Yeah. So this is the one solution. Uh, well, yeah, hashing is the second solution, right? So we can use the hashing. We can simply use a hash map, and we can uh, simply count the frequency of each element in the array, right? So the frequency of each element should be equal in both the arrays. If that's the case, then they are equal, right? So here we can use hashing. So these are typical use cases of hashing. Let me know if it is clear. Yeah, let me know if everything is fine till now. Okay, yes, we can do, so hashing will take O of n time because we are doing simply hashing. So O of n time plus O of n space, right? Because we are using hashing. Here we are not using any extra space, so it is simply n log n and O of one space. Okay. Again, you can use two loops, right? Like for each element in this array, you can iterate in the array. But again, for duplicate values, that will not work. So yeah, so these are the two solutions that will work. Srijan is asking, can we solve this without hashing? Sorting is one way. You can solve using two loops as well if you can try uh, in a better way. So just think, right? And just think about other solutions. But like XOR will not work here, right? How? Okay, yeah, XOR will work. So Palak, you're right. So XOR will work here. So okay, I'll talk about the XOR solution when we'll talk about bitwise. Yeah, so XOR will work here because here we'll have some elements. Yeah. So I'll talk about XOR solution when we will talk about bitwise operations. XOR is a bitwise, right? It is a Boolean operation. Like in Boolean operation, we have OR, we have AND, we have XOR. XOR is this operation, XOR. Yeah. Muskan is asking why hashing used other than array if it takes more space, because hashing is helping us to do something in O of 1, right? We can insert, delete, and search in O of 1 time using hashing. That's why hashing is best, right? Hashing is the, I would say, most used data structure because it is, I mean, we are doing a lot of things in O of 1, right? So that's why hashing is that useful. Yeah. Well, Dia James is saying space complexity will be more than O of n. Yeah, it can be more than O of n. Like it can be 2n in worst case, but again, it is the range of O of n, right? 2 of n is also similar to O of n. That's why it is O of n only. Yeah, but yes, it can be more than n. Okay. Well, so just give me a break of 1 minute. I'll be back, and then I'll discuss some more questions. Just give me a break of 1 minute, right? In the meantime, you can try. Okay, so you can try one more question. The question is, uh, well, okay. Let me get that problem for you. Okay. Looks like, uh, hmm. So the question is simple. let's say we have an array like this: 10, 20, 15, 50, 60, 13, 30, and 19, and so on, right? Let's say we are given a sum called, let's say, 35, right? So we will simply check whether we have a pair that has sum equal to 35. Like here we have a pair, so output should be true. If sum is, let's say, sum is 200, we don't have a pair, right? So it will be false. So we have to check if we have a pair that has sum equal to the given sum, that is true, otherwise false. So it's a Boolean function called has pair, and we'll simply check if we have a pair which can have sum equal to this given sum. If that's the case, return true, otherwise false. Take a break of 1 minute. I'll be back in. And in the meantime, you can try solving this problem. It's a very common coding problem, right? Well, I'm back then. So, okay. The question was to check whether we have a pair which can have the sum equal to given sum, right? So, uh, let me explain it again. Yeah. Again, these two numbers can not be contiguous, right? Like, let's say if you have sum equal to 28, right? So it's true because we have two numbers, this and this, which can have a sum to 28, right? So these numbers can be anywhere, right? But it's like we should have two numbers, x and y, which can have sum equal to the given sum. If that's the case, return true, otherwise false. So in the input, we'll have this array and we'll have this sum. We'll have to check whether we have a number, a pair which can have the sum equal to the given sum. So that's the problem. Sliding window technique. Mhm. Yeah, they might not be adjacent, right? So it's being adjacent is not compulsory. Yeah, the one solution from Dharmendra is using two loops. Yeah, that's fine, right? So we can use two loops. That's the simplest method that we can think of. Let's say method one, right? Okay. So yeah, so what we can do is we can simply check. We can have two loops, right? For I equal to 0 to n, and then for so we'll check each and every pair, right? I plus 1 to n. So if this pair, like array of I plus array of j, if the sum of this pair is equal to the given sum, then return true, right? Otherwise, in last we can return false, right? So that's the simple method. But the cost of this method is n square, because we are using two loops. We are simply checking each and every pair, right? So can we optimize it? Can we do something? Yeah. So another solution could be, if I talk about method 2, again, if you talk about sorting, sorting also helps us in searching, right? So if we have sorted things, then we can search things in login time, right? So again, for searching, hashing is the best, right? Because we can search something in hashing in O of 1. But sometimes sorting also can help us to optimize the searching, because if something is sorted, we can search in login time. Yeah. So here the idea is simple. Let's say if you have something like this. Let's say if you have data in the sorted order, like this, let's say 15, then let's say 20, 30, 60, and so on, right? Let's say the given sum is 45, right? So we can simply do like one thing, like we'll have two integers I and j. We'll simply find the sum of this number and this number. So it is greater than, let's say given sum is 45. So 5 plus 75 is greater than 45. That means that pair must be in the left side, right? Like, I mean, again, in the left of this number, we can get a small number. So that might fit in the pair. So we will shift to the left number. Like we'll do j minus minus, right? Again, we'll check like 5 plus 65, 60, which is again more than that. So again, we'll do minus minus. So we'll be at this index, right? Here we have like 5 plus 35 it is not less than 45, right? So if that's the case, if this sum is less than the given sum, in that case we'll have to move forward, like we'll have to do I plus plus. So we'll be at this index. So now again 10 plus 30 is less than 45. So we again do plus plus. So we'll be here. Again, this is also less than that. So we'll be again at here, right? So now this plus this is 45. That means okay, we have a pair. So that's the logic. Sort the array, use two pointers I and j, or two indices I and j, and move them depending on the sum of the two numbers at ith and jth index, right? Okay. So again, I can share this complete code with you. Like you can simply find this code. Like I'll be sharing all these things. Right. So actually, I already shared that. I mean, the link of the document. Right. Looks like you don't read my comments. So let me show you once again. Just give me time. I'm simply going to share that Google Doc where you can find the class notes, I would say. Yeah. Let me share my screen again. Yeah. So what you can simply do is, if you can search and go to YouTube, right? You can simply search on GeeksForGeeks, and on like in the week 1 and day 2, right? On this topic, here I have made a comment, right? So I have shared the Google Doc link. Okay. So you can find the content here, right? You can find the class notes here in this Google Doc. Yeah. Like if you can open this, I'll share this link. I mean, in this comment as well, right? But here you'll have the class notes for each lecture in the same doc, lecture 1, lecture 2, and so on, right? So I'll be adding all these things in this doc. Yeah, so I'll share the link of this doc again in the comments of this video. once I'm done with this session. But yeah, you can find that in this video. It's also on YouTube, right? Fine. So again, in that doc, you'll have every, I would say, every link, right? I mean, everything. So like the link of every question, so that you can have a look at the complete problem and the complete working code, right? Yeah. So I'm not writing the code of everything here because we don't have enough time. But if you want to have a look at the complete code, you can simply go through those links, right? I'll be sharing all those links in that Google Doc where you can find the class notes and everything. Yeah. Well, so I hope this is clear, like how sorting is helping us to find that pair of that given sum, right? So the cost is n log n for sorting, and this the n for this, this loop for ij loop, right? So O of n log n plus O of n, which is n log n. Space is O of 1 in the method 2. So it is better than n square, the method 1, it is n log n, but we can solve in O of n using hashing. Yeah. So using hashing, we can solve in O of 1. And how we can do that? How we can solve this problem? Yes, we can use a hash map, right? We can use a hash map. Yeah. We can use a hash map, and we can simply put all these values in the hash map, and we'll simply check. Like, let's say if we have 15 in the array, right? And when will be at 30, right? So we'll simply check, do we have 50 minus 30 in the array? Like, do we have 15 in the array? I mean, 15 in the hash map. If that, I mean, 15 is there, that means okay, we can have a pair, that can have that sum, right? So basically, this is how we can do. So we can simply insert everything in the hash map or in the hash set, and yeah, we can simply check if we have, a complement of that number. Yeah. Please repeat this method, okay? Well, so what I was saying is, let's say we have numbers like 5, 10, 30, 20, 13, 15, let's say 40, and let's say 37, right? Let's say x is, let's say sum is 45, right? So what I'll do is I'll iterate in the array and I'll put them in the hash map or hash set, right? 5, 10, and so on. Okay? So while putting, we'll simply check. So when we are pushing, let's say putting 30 in the hash map, we'll simply check, or hash set you can say. Do we have a number 40 minus 45 minus, the sum minus 30 already in the map? If that's the case, that means okay, we have already a number 15 in the hash map. That means okay, we can have a pair, right? But when we'll be at this number, we don't have that number, right? We don't have 15 in the hash map. So similarly for 25, 20, we'll push it 20 in the array, then we'll push, let's say 13, then so on, right? When we'll be at 15, we'll simply check, do we have sum minus 15 in the array? Like, do we have 30 in the array? 30 in the hash map? Yes, we have, right? And we can search that thing in O of 1 because searching in hash map is done in O of 1, right? So that means, okay, we have a pair with sum 45. So this is how we are checking whether we have a pair with a given sum. I hope it is clear. Yes, it is easy, right? Yeah. Is it clear now? Mm. Yes, Misha. Yeah, that thing can be done. Like, we can simply subtract numbers from the sum, and if sum reach to 0 in the next iteration, we are done. Yeah, that is another way of solving it. Yeah, that's also correct. Mhm. I'll share the link where you can have the complete code, right? So I won't be writing the complete code. Okay, well, okay, let me write the code for you so that, so I'm going to write the code for method 3. Yeah. For method 3, right? Let's say we have function has, we have the array, we have the number n, and sum is the given sum, right? Let's say I'm going to implement a map. Let's say we are going to use a set, right? So because we don't need a value here, we key is fine. Like let's say we have simple unordered set, right? Yeah. So in this set we'll have unique values, right? What I'll do is I'll simply put in the array I less than n, I plus plus, right? I'll simply check if sum minus this array of I is there in this set, right? Like if set dot contains means we can simply check whether we're simply searching, right? So searching means there is one more function called find, right? You can see the syntax, right? I'm not writing the syntax, exact syntax here. So basically, if there is a number called sum minus array in the set, that means okay, we have a sum, right? So we can return true. Otherwise, what we'll do is we'll simply insert this number in the that's we're doing. The number is already there. We are done, right? And if complement of that number, like let's say when we are at 15, we are checking if 45 minus 15 is there in the set, right? That is in the set that, and then we're returning true. Yeah, so this is a simple code. Otherwise, return false. I hope it should be clear now. Well, okay. Any other questions? Yeah, it will take O of n space, right? So this will take O of n space, but we are solving it in O of n time. Yeah, insert is a function, right? Insert is an inbuilt function. Yes, it cannot hold duplicates, right? Yeah, that's correct. Yeah. Well, let me take few comments and then we'll start solving more questions. Uh, let me know if you have some more doubts so that I can help you. Well, let me quickly discuss one more problem on hashing. Right. Well, the question is we have to find a winner of an election, right? And here votes are represented as names, as strings, right? Like let's say we have an array of a string called votes, and first element in that votes array is John. John means, okay, so basically the first vote is given to John, right? Similarly, the second vote is given to Johnny, then third is to Jackie, then Johnny, then John, then Jackie. So basically, I mean, like here John has got 3 votes, right? I guess 4 votes, right? Jamie has 2 votes. Johnny has again 4 votes. Jackie has, I guess, 3 votes, and so on, right? So uh, the I mean the I would say the guy with maximum number of votes will be the winner, right? So we'll have to find the winner if we have this given array of strings, right? So let's say for now we don't have like 2 or more candidates, they don't have equal number of votes, right? Let's say we have clear winner, right? Let's say we have someone which has the maximum number of votes, so we have to find that winner. And so we'll be given an array like this, and we have to find the winner. Yeah. Okay. Like let me make it. If we have something like this. Let's say this is John only. Right? So this is John. Now John has 5 votes, right? That's why John is winner. Okay. Basically, the user with maximum number of votes will be the winner. So we have to find the winner if we have this array of strings given. So how we can solve this problem? Right, yeah. So we can simply use hash map, and in the hash map we can store the frequency of each string, right? Okay, and that will help us to, you know, yeah. So with the help of hashing, we can find the frequency of each string, and the string with maximum frequency will be the answer. Yeah. Yeah, hashmap is the best solution, right? Again, here you can find the complete code on this link. Right? Actually, in this question, there is a one twist. The twist is if there are more candidates with same number of votes, in that case, the winner will be the candidate which has the alphabetically smaller name. Like John and Johnny has the same number of votes. So John is the winner because John is alphabetically smaller. Yeah, that's the twist. So again, but the idea is this question can be solved using hashing, using hash map. And to tackle the duplicate case, you can think about it a little bit, and of course, you can see the complete logic and code here. I'll share all these things with you on that Google Doc itself. Yeah? Well, so actually, I'm done for today. Also, in that Google Doc, see, also on the tracks, you will find a lot of practice problems on hashing, on sorting, on searching, on arrays. So you can try all these things. And then next week, we'll start with recursion. Right? So I'll talk about recursion on next Wednesday. And then we'll start beatwise and some other things, right? So, yeah. So in third week, we'll talk about recursion and bitwise. Okay. So make sure that okay, you have solved all the questions, or I would say most of the questions based on array and strings. Sorry, array and hashing and sorting and searching. Yeah. So I can take a few more questions based on placement and DSA or anything, right? So and then we'll finish the session, right? From next week, we'll try to extend the duration. Like the current duration is 6 to 8 p.m. But we will but like the timing could be, let's say, 6 to 7:30 or something. Sorry, 8:30 or something, so that we can cover more and more questions. Yeah. So Gaur, I just shared like how to access the invitation code, right? So I won't repeat that thing again and again, right? Okay. Is learning C++ worth for interview? Yeah, I mean, you can learn any language. So you can learn C++ or Java or Python or anything. But C++ is the easiest, I would say. So you can go with C++, and it's not that tough, right? So you can learn in 1 week. Okay. I mean, if you know a language, like if you know C, then you can learn C++ in 1 week. You don't need to learn everything in C++, right? Just the STLs and basics of C++, like how to write if-else loops and functions and methods, and that's all. I mean, you don't need to know about exception handling or file handling or other things. Yeah. Uh, yes, we can use. I mean, you can use inbuilt functions, right? But you should know how these things work. Like how, let's say if you're using insertion in a hash map, then you should know how insertion works in hash map and what is the cost of that operation. But you can use the okay. How to synchronize sorting of real world data is done. Well, it depends on the type of data we have, right? Okay. So see, I mean, if you can see the code of C++ or if you can see the code of Java, so they have the code of inbuilt sorting function, right? So it is similar to quicksort. Yeah. So they use similar to quicksort for arrays. But let's say if you're sorting linked list, then you will have to use merge sort. So it depends on the type of data and the type of collection that you are using. Yeah. Uh, okay, I mean you can't compare, right? Like both are good, right? And but if we talk about the more jobs in Java, you can find a lot more job, right? Because Java is used for multiple things. It is used for Android. It is used for backend development, right? So Java has like more companies are using Java for their development than C++. That's why, and from jobs perspective, Java is little better than C++. But again, if you know C++, then you can learn Java in, I would say, in 1 week, right? So switching from one language to another language is not that tough, right? Like you can learn, or you can switch from one language to another in 1 week. Yeah. अर्चित यार तुम्हें मतलब ओके सो तुम्हें जावा अलग से सीखना मतलब ये कोर्स जावा के लिए नहीं है राइट यू नीड टू learn Java by I mean with the help of GeeksForGeeks or with the help of some YouTube videos, right? This course is for DSA, right? So if you want to learn Java, then you can learn from GeeksForGeeks or you can learn from there are many sources, right? You can learn from YouTube channel or many things, right? Hmm. Well, okay, so I'm from Bihar, right? So I'm from Motihari, Bihar, and life is going good, right? Yeah. Can we apply DSA on other programming language like Python or Java? Yes, you can apply. Like I was using Java code, right, for DSA, right? So you can use anything, and you can apply that DSA concept in solving some real life problems. Like you can, let's say, if you're developing something, then you can use that DSA concept, right? Sorry. Okay. Sorry. Well, if you know only Python and use it for CP, then is it possible that the interviewer expect me to know ML or data science just because I know Python? No, no, that's not the case, right? You can know Python without knowing ML or something, right? So it is fine to know Python. Okay, so you can put in Python, and they will not expect you to know Python if you have not mentioned those things in your profile in your resume, right? So they don't assume things, right? Uh, well, so that's a different. I mean, sorry. Okay, selecting questions are really tough in the live chat. Okay, so again, you have watched a video of hash map, right? So I just written like, what is the core logic behind the hash map? The core logic is to make things in O of one, right? Like you can do searching, deletion, in hashing in O of one. So that, so sorry, insertion, deletion, and searching in O of one. So that was the main idea. But how hashmap is implemented in Java, you can watch some other YouTube videos to know that, right? But that is the basic concept. And that is the base concept that I talked today, right? Uh, well, what is the scope of well? Okay, like these things will help you to get a job in machine learning. Like some companies have profile called ML engineer. So if you are applying for that profile, then these things will be helpful. But for normal SD roles, I mean, anything is fine. So you can do something in ML, you can do something in machine learning, you can do something, sorry, you can do something in front end, back end, you can do something in Android. So anything is fine, right? Any project is fine. So they don't care about your domain unless you are applying for that specific domain, right? Let's say if you're applying for ML engineer, in that case, you should have some good ML projects. Otherwise, for normal SD roles, they don't care about AI/ML. I mean, you can get a job without knowing AI/ML. Like I don't know AI/ML, and yeah, so but it's a good thing to know. Like I mean, I'm learning this thing, so yeah, these things will be helpful. Uh, hmm. Yeah, Geeks for Geeks itself, right? So on Geeks for Geeks, you can find a lot of things, right? And on Geeks for Geeks itself, you'll have a lot of questions that you can practice to improve the coding or problem solving skill. Yeah. Uh, Opinion for learning front end. It's good. It's a cool thing, right? You're building the UI for a user. Right? So it's a cool thing. You can learn JavaScript, and then you can learn any framework like React.js or AngularJS. I know React.js, so I prefer React.js. But it's a cool thing that you can learn front end development. It's a really cool thing. Uh, hmm. For CP, the best language is C++, right? It's not Java or Python. But if I compare it to Java Python, I would say Java is better than Python for CP. I mean, it depends on a lot of things, right? So it's not a simple comparison, I would say, because Python has a smaller syntax, so Python code is easier to write. Okay. Okay, I'll take few more questions, right? Okay, the difference is SD2s are paid more than SD1s. So that is the difference. Like SD2 are paid more than SD1. So you'll have better salary. That's the difference, right? Okay. And normally freshers uh, will be given that post as SD1. But if you have experience of 2 years or 3 years outside, then you can get that title SD2, right? Well, to know that, you can do internship, or I mean you'll be doing similar coding, right? So it's not different. Like you'll be doing similar coding. You'll be writing code in Java or C++ or in Python or in JavaScript or in Scala or in Go, but you'll be writing similar if else and loops and similar code. Uh, yes, they can tell you to implement your own hash map or hash set, right? So you should know how these things are implemented. Yes, I mean Java has a very bright future, right? So a lot of companies are using Java, and I would say Java is the I would say it is the most widely used language. So I mean, if you know Java, then you will have better options for. Again, companies, when good companies won't care about your language, but there are some companies which like, and they hire specific to a language. Like, so in that case, Java has more demand, right? If I compare with Python or C++ or JavaScript, so it has a good future. Okay, last. Okay, last question. I'm waiting for some good question, right? Yeah, sorry, it's okay. The question was the future of Go. Yeah, it's a good language, right? So Go, I mean, Go is developed by Google, so it's a really good language. So yeah, it has a bright future. Well, so yeah, I'll take this question. If not Fang, what all companies are good? Well, it's a long list, right? Like apart from Fang, the good companies are Microsoft, Uber, Adobe, Walmart, Salesforce, Cloudera. Uh, then we have uh, Oracle, uh, then eBay, Flipkart, Swiggy. I would say, I mean, again, this companies like QuerFeet, Donjo. There are many companies, right? Again, Disha, Goldman Sachs, uh, like Expedia, Paytm. All these are good companies, right? Yeah, and if it again, Microsoft like is not in the FANG, but Microsoft is like it is a FANG level company like Microsoft. Then again, Airbnb, then Adobe. Yeah, so all these companies are in that league. Then companies like Box, Dropbox, LinkedIn, right? LinkedIn is a really good company to work with. Tower Research, Direct Eye, Rubrik, right? Uh, there are many companies. I don't remember all the names, but then there is a company like there are many companies actually. So you can simply you can do one thing. You can simply go to Glassdoor and you can see the salaries of all these companies, like like how much they pay. Right? So if a company is paying really high, I mean a really good amount of money, that means it's a good company. That's a simple way of comparing the companies, right? So good companies pay good salary. Yeah. Yeah, I might be missing some names, right? There are many companies. Yeah, data is there. Data is really good company, right? So, okay, I am done for today. Uh, so in the next lecture on next Wednesday, I'll talk about recursion. Recursion, right? So recursion is very important for solving questions on trees and DP and graph. So we'll talk about that, right? So, okay, last question from Srishti. What should be skills in a student to? Yeah, I mean, the first thing is being good at coding, being good at problem solving, being good at DSA and algo, right? Apart from that, you should know the CS fundamentals like how operating system works, what is memory, what is paging, what is segmentation, what is database, what is a table, what is DNS, what is TCP, right? So you should know the basics of OS networking, TPMS, and OPS. You should know one language. You should build something. You should build a project. You should build one or two projects, right? Yeah, so again, the main thing is JSON algo. Apart from that, you should know all these things to get a dream job. Okay, thanks. Okay, thank you. Yeah, so make sure that okay, you know the basics of recursion. That will help me to discuss things easily, right? So if you can read about the basics of recursion, that will be really helpful, right? So just try some questions on recursion, and then we'll start recursion on next Wednesday. Okay, then. Thank you. Bye.